Ladies and gentlemen, welcome to section 12.6, Permutations and Combinations. Let's go ahead and start things off with permutation. Permutation is an arrangement of object in which order, keyword order, is important. It's all about order for permutation. So let's go ahead and jump right into things. How many ways can you arrange the letters A, B, C? Well, let's go about this. I'm going to arrange them here. Well, one way I have A, B, C. Sticking with A being first, what else can I do? I could go A, C, then B. Okay, so I use my A being first. What's another different way? I can go B first, and then I can go B, A, C. And then I could go B first again, and go CA, and then finally I can use my C's correctly, and I can go C, A, B, and C, B, A. So now how many ways can I arrange these letters? I can arrange them 6 different ways. So let's go more in depth here. Well, we just found a factorial. A factorial is this little exclamation mark right here. In math, that means factorial. And when you have that, it's going to be 4, the number that starts here, 4 times 3 times 2 times 1. Well, let's go back up to this example. How many different letters did we have here? We had 3 letters, so it should have been 3 times 2 times 1, which is 6. We came up with 6. Another example here, Lloyd and 5 friends go to a movie, and how many different ways can they sit together in a row of 6 empty seats? So if we let 6 empty seats be 1, 2, 3, 4, 5, 6, right here, we have 6 total friends and 6 empty seats. So of those 6 friends, how many people can sit first? 6 friends, how many people can sit first? 6 of those. Now one person sits here. How many can sit here? Well, there is one person here sitting there. There are only 5 left. There is one person there. Now, how many people can sit here? Since there is one here, one there, only 4 can sit there. 3, 2, and 1. And then you would multiply these up for your answer. But that is how we work out a factorial. A permutation now is calculated, is written as P and then NR. In your calculator, there is a button for permutation and combination, which we'll find out, and factorial in your calculator, but I will show you those in class. This is a longhand version of how to write it. Again, this exclamation mark is a factorial. So let's take a peek at some of these. We have a word processing program requires a user to enter a 5-digit registration code made up of the digits 1, 2, 3, 4, 5, 6, 7. No digit can be used more than once. How many different registration codes are possible? Well, first we have to find what's our total amount. We have a total of what? We have a total of 7 different letters, or 7 different numbers. There is our total. We are picking how many? Well, how many are we allowed? We are allowed a 5-digit registration, so we are picking 5. Now, how do I know that order matters? Well, in passcodes, order matters. So that tells me that it is a permutation. So let's go ahead and do this mathematically. So I have 1, 2, 3, 4, 5. Here's my passcode. How many letters can go here? 7. How many letters can go here if I put 1 there? 6 can go there. And then I'm using 2. So how many can go here? 5, 4, and 3. Notice how we don't take this times 2 because we don't have space for the other 2. So you can write it like this, and you multiply these all together to get 2,520. Or what else could we do? We could use this in our calculator. And we go P and 7, 5. And what's that mean longhand? This is 7 is our n, so we're going to put it in for n. So it's going to be 7 factorial divided by, and then this n is still 7. 7 minus 5, because that 5 is where the r is, factorial. It goes 7 factorial divided by 2 factorial, which equals 2,520. Number 2, we have James wants to place 5 of his 8 trophies on his fireplace. How many ways can he arrange his trophies? Well, arrange, if I have a first place trophy here and a second place trophy here, is it different than second and then first? In my arrangement, it is. So that tells me that it is a permutation. So let's go back. How many total trophies do I have? I have a total of 8 trophies. I am picking 5 of those trophies. So I have 1, 2, 3, 4, 5 places to put my 8 trophies. How many trophies can I put in that first spot? I can pick or put 8 in that first spot. I can choose from 8. Well, I put 1 here. How many are left there? 7. I put 2 here. How many are left for the next spot? 6, 5, and 4. When we're talking about permutations, we multiply them together to get 6,720. Or if you want to use this guy, it is a permutation. Our n, the total amount, is 8. We are choosing 5 of them, plugging them into this formula. Our n is 8, our r is 5, and so we go 8 factorial over 8 minus 5. And that also gets a factorial. 8 factorial divided by 3 factorial, which comes up with 6,720. So either way works. This way takes a little bit longer when we have bigger numbers. Now I am asked how many different ways can I put the letters A, B, C, D into groups of 3. Well, if I start off with A, B, and C, is this group any different than B, A, C? We have the same group members, yes? So BAC is the exact same group as ABC. And that leads us into a combination. A combination is an arrangement or listing in which order is not important. So not important goes with combination. The formula for combination is here. We are dividing out, this R stands for, ladies and gentlemen, dividing out something like this, the BAC, the repeats, where it's the same group members. We are taking those out in a combination. Here we go with some combination problems. Now with 3, a group of 4 students is selecting corsages and boutonnieres to wear into the spring dance. They choose from 4 roses, 6 carnations, and 8 tulips. If all the flowers are different, how many ways can 4 flowers be chosen? Well, first things first, what is the total? The total, when we add all the flowers up, the 6 plus the 4 plus the 8 turns into 18. We are choosing 4. Now, does it matter how we rearrange those flowers, those 4 flowers? It does not. It does not matter. So we have 18 choose 4, or we have it like this, 18, 4. If I write it out for you, we have 18 factorial over 18 minus 4 factorial times 4 factorial. Keep going with it. It's 18 factorial over 14 factorial times 4 factorial, giving us a final answer of 3,060. Trying another one. We have a group of 4 seniors, 5 juniors, and 7 sophomores have volunteered to be on a fundraising committee. Mr. Davidson needs to choose 12 students out of the group. How many ways can he choose 12 students? Well, first things first, find the total. The total is going to be the classmen, or the upperclassmen, so it's 4 plus 5 plus 7, which gives me a total of 16. We are choosing how many? We are choosing 12. And why do we know that this is a combination? Because we're talking groups. Anytime where you hear group, the order doesn't matter. That's where we get the combination from. So let's go ahead and use our formula where it is 16, choose 12, and if I use my algebra, it's 16 factorial over 16 minus 12 factorial divided by or multiplied times 12 factorial, giving me 1,820 different ways that Mr. Davidson can choose his groups. Now we're just going to help with some identifying permutations or combinations. For 5, a fire drill, or during a fire drill, a teacher checks the students in her row to see if everyone is present. Does order matter? Well, during a fire drill, I'm checking to see if all my students are there. I don't care what order they are in, as long as they are all there. Order doesn't matter. So if order doesn't matter, we have a what? We have a combination. 6, in preparing for a competition, a tennis coach lists his players in order. Here it says order, so what do we have? We have a permutation. 7, a teacher uses a random number generator to create a seating chart for 20 students. Does it matter where you sit? Yes, it does. So since it matters, since order matters, we have a permutation. 8, we have 10 athletes enter a race. The top 3 finishers move on to the next round. Does it matter what place you finish in? First is the same as third as long as they all move on. So since order does not matter, we have a combination. Now one more problem here that we're going to work on with is a probability problem. First thing here we have to figure out, is it a combination or permutation? 16 people signed up for a table tennis tournament. If the players are put into groups of 4 and the draw is determined randomly, what is the probability that Heather, Aaron, Michelle, and Patrick are put into the same group? What is our total? Our total is going to be 16 people. How many are we choosing? We are choosing 4 per group. And since we are talking group tells us that it's going to be a combination. So how many different groups can we have? Well, we can go choose 16, 4, or we can go, other teachers can write it 16, choose 4, but our book writes it like this. So we have 1,820 different groups that we can possibly have. Now, with 1,820 groups, how many groups can Heather, Aaron, Michelle, and Patrick be put into? Well, there is only one possible way for them to be put in a group, right? And it's having Heather, Aaron, Michelle, and Patrick all in one group. So there's one way for those guys up there to be put in a group. So if we're looking for probability, the probability for this group is going to be 1 out of a total of 1,820. So please make sure you know what the question is asking. And that does it, ladies and gentlemen, for section 12.6, permutation and combinations. Good day.